Talk about percent proportions. This can be a hard topic for some kids, but really the whole thing is you're really going to have to think about your problems. Sometimes there's going to be information that you need that is not given to you. So let's jump right into it. What is the percent proportion? Well, the percent proportion looks like this, and we can see four different parts. We see 100%, and that's going to represent the whole or the original amount of something. Then we have another percent. This percent represents some part or some portion of the whole. It's important that you know that that percent, yes, it can be greater than 100. And then we have the part. The part represents a portion or a piece of the whole. And again, it can be smaller than the whole. It can be larger than the whole. That's a hard concept for kids to realize that it can be larger. And the whole is just your whole or your original quantity. So, how do we use the percent proportion? We are going to need to read our problems carefully. And then you're going to identify important information. If you have like a highlighter and you can write on paper, you're going to want to highlight or underline important information. You're going to reflect on what you know in the problem. And then you're going to determine information that you can figure out, even though the problem doesn't explicitly tell you this. This is what's very important about working with proportions. Percent proportions anyway. You've got to make sure that there's missing information. Can you figure that out on your own? Identify the question or the problem you're trying to answer. Just because you get an answer doesn't mean that it is the answer that the problem is asking you for. And we're going to use a variable to represent an unknown value. Remember, a variable is a letter or symbol that represents a number. A lot of times we use X. It doesn't have to be X. It can be any letter. And then we're going to write the appropriate numbers into the percent proportion. And you'll notice that after the numbers, I'm putting unit labels, and that's going to help you decide which numbers go in which positions. It is very important that your unit labels are lined up. If you have different labels in next to each other, then something's probably wrong with your proportion. And finally, we're going to use cross products to solve the proportion. Remember, you can also use scaling, but most of these problems are going to be too difficult to scale, so you're going to want to use cross products. Okay, so here's example 1. 16% of the animals at a pet store are frogs. If there are 12 frogs in the store, how many total animals are in the store? So important information is that the 16% is the frogs. And even though 16% represents the frogs, there are actually 12 little frogs hopping around in the store. And we want to know how many total animals. So here's where, before you begin your problem, you really need to think. What do I know? I know that 100% represents the total animals. I know that 16% are frogs, and I know that there are actually 12 frogs hopping around in the store. Now, what can I easily figure out? I can figure out if I take the original 100%, which is the total, subtract out the 16% that are frogs, that must mean that 84% are not frogs. And what do I want to know? I want to know the total animals in the store. And I'm going to let that be my variable because I don't know what it is. Now, if you notice in our thought bubble, there are different numbers there. We'll use some of them. We won't use some of them, and that's okay. So the first thing you need to do is write your percent proportion. Percent over 100% equals part over whole. Then we're going to start placing things where they go. So my 16% represents the frogs, and my 100% represents the total animals in the store. There are actually 12 frogs hopping around in the store. And I don't know how many total animals there are, so I'm using my variable. I need you to notice here, you see how frogs lines up with frogs? And you see how total lines up with total? That's what I mean when I say make sure that your unit labels are lining up. If they're not, there's probably a problem in the way you've got things set up. So we're going to use cross products, and anyway, we're going to use cross products, and 16 times n is 16n, and then 100 times 12 is 100. And so now I've got the equation 16n equals 1,200. Okay, when I have an equation, I want to isolate the variable or get that n on the left side by itself. Right now, this n is being multiplied by 16. To undo multiplication, I have to divide by 16. But what I do to one side, I do to the other. 16 divided by 16 is 1. That leaves me with 1 n, and that's going to be equal to 75 total animals. And that's the answer to my question. And we're ready to move along. So the next problem says the original price of a book was $12.50. The book is on sale for $7.50. What percent of the original price is the sale price? So before we do any work, we're going to stop and think. I know that 100% is going to represent that original price. And according to my problem, $12.50 is my original price. Also, according to my problem, the sale price, which is the price I paid for the reduced book, is $7.50. Okay, so what can I figure out? If I take the $12.50 that was the original price and I subtract out $7.50, that was the price that I actually had to pay for it. That means a $5 discount was taken off the original price, correct? And then what I want to know, well, I want to know what percent of the original price is the sale price. I'll let that be my variable. So the first thing I'm going to do is to write my percent proportion. Percent over 100% equals part over whole. And then I'm going to start plugging in numbers where they go. Well, I don't know the percent that represents my sale price, so I'm going to use a variable for that. I know 100% represents the original price, and I know that $7.50 is the sale price because the problem told me so. And I know $12.50 is my total or my original price, and the problem told me that as well. So now to solve, I am going to do cross products. So n times 1250 is 12.5n. And 100 times 750 is 750. Now, my equation says 12.5n is equal to 750. I need to get that n by itself. Right now it's being multiplied by 12.5. So to undo multiplication, I'm going to divide that side by 12.5. And what I do to one side, I do to the other. 12.5 divided by 12.5 is 1. That leaves me with 1n is equal to 60%. So 60% is going to represent the sale price. So that means I only had to pay 60% of the original price to buy that book. It's not bad. Let's go to the next one. Example 3. It says there are 80 pieces of candy in a bag. Mr. Olson gave 30% of the candy to his students. How many pieces of candy remain in the bag? So I'm going to think, well, what do I know? Well, I know that 100% represents the original amount of candy in the bag. And I know that there were 80%, there were 80 pieces of candy in the bag originally. And I know Mr. Olson gave 30% of those pieces to his students. So what can I figure out? Well, even though the problem doesn't tell me this, I can figure out if I take the 100% and I subtract out the 30% that Mr. Olson gave to his students, that means that 70% of the candy has to be left in the bag. And what do I want to know? Well, I want to know how many pieces of candy remain in the bag. So I'm going to use my percent proportion, and I'm going to use all these things that I now know and start putting them in the appropriate places. So 70% of the candy remains. And the problem didn't say that, but I figured it out. And I know 100% represents the original amount of candy. Now, I want to know how many pieces remain, but I don't know that yet. So I'm going to use a variable. I'll use X. And I know that there were 80 pieces of candy in the bag originally. To solve this, I'm going to use cross products. So I'm doing this kind of backwards. I know 100 times X is 100X. And I know 70 times 80 is 5,600. So I have an equation over here that says 100x equals 5,600. Well, I want to get that x by itself. Right now it's being multiplied by x. So to undo the multiplication, I'm going to divide by 100. Once I divide one side by 100, I need to divide the other side by 100. And that's going to give me, and that should be an x, not an n. That should give me x is equal to 56 pieces remaining. So there are 56 pieces of candy in the bag. Now, example 4. It says the original size of the band was 75 members. That's pretty big. The next year, the band added 15 additional members. What percent of the band size, what percent of the original band size does the new band size represent? So I've got to think about this. Now, I know that 100% represents the original size. But remember, the band got more members, okay? 75 members were originally in the band, but they added 15 members. So even though my problem doesn't tell me, I can figure out if I take the 75 original members and add it with those 15 new members, that's going to give me 90 members in the new band. And I want to know what percent of the original does the new size represent. Remember, the new size is bigger than the original size. So that should tell you about something, the percent that we're about to calculate. So my percent proportion says percent over 100% total equals part over whole. I'm going to plug in some information. I'm going to let H percent represent the percent of the new size. Like that's the percent that represents the new size. And 100% represents the original. Now, the new size of my band is 90 members, but the original size of my band was 75. So now I'm going to do cross products. So 75 times H gives me 75H, and 90 times 100 gives me 9,000. So now I'm going to divide both sides by 75, and that gives me that H is equal to 120%. And you might be like, well, wait a minute, that's bigger than 100. It's supposed to be, because remember the original size, which was a smaller band, was 100%. The original size is 100. If that band grew, then my new size is actually going to be greater than 100. In this case, it's 120%. So thanks for watching.